Welcome to the session. Today's session we will look into the types of machine learning. So this is the general flow chart of the different types of machine learning. So under machine learning we have supervised learning, unsupervised semi-supervised learning and reinforcement learning. So supervised learning can be further classified into classification and regression. Unsupervised learning can be further classified into cluster analysis, association mining and even dimensionality reduction. Before we start about the types of machine learning, let's first discuss data. So data is the most important, as we have discussed earlier. Machine learning data is the most important and the first step in the machine learning algorithm. So basically data is just a raw fact, right? It can be represented in various ways. Data can be represented as a table, image or audio, video, or it can be a video frame. Normally it's represented as a table, right? So the features, let it be an input, can be an image, input can be a video frame, but you can extract the features from these images and make it in the form of a table. So what are features? Features are actually attributes, or they are characteristics of data, normally which is represented in the form of a table, and the column of the table we call it as attribute. And one important attribute in the column would be the label. So label is actually the feature that we aim to predict. So suppose I have some I am trying to classify the flowers, right? So there are, suppose let's say there are the three types of flowers: iris setosa, iris virginica and iris versicolor. So these are the various characteristics of the respective flowers, right? So the length of the petal, width of the petal, length of the sepal and width of the sepal. So these are the features, right? And class is nothing but the label, right? And the goal of machine learning is to identify, right, which flower it is based upon these characteristics or attributes, based upon the length of the petal, width, length of the sepal and width of the sepal. So there are two types of data, in fact. One is called as a labeled data and unlabeled data. So labeled data is basically where the data we are giving labels like this, right? So labeled data is actually used in the supervised learning. We can also have like, or maybe this diagram, right? I'm giving an input, I'm giving the label that this is a dog, and giving this giving images of cats and giving a label to it as a cat. So basically I'm giving labeled data for the machine learning algorithm to learn. So that's a labeled data. We also have something called as an unlabeled data, where we don't give this label. The algorithm has to learn based upon the patterns of the data without any label. So let's first discuss about labeled data. As I told you here, right, this is the iris flower data set, right? Or if you actually search for Fisher's iris data set, you can download it easily and use it for your algorithm. So let's say I have 50 samples here of this kind of flowers, and there are 4 attributes here: length and width of sepals and petals, and the target variable is basically the class or the label. So there are 3 classes or 3 labels here depending upon the 3 different flowers. So this is actually what I'm showing is just a partial data set. Normally in our when we are working, we need to have a very, when we are trying to train our algorithm, we usually have a very big data set. So data set, now there is no rule that it has to be a table like this. It can be an image, it can be a video frame also. In fact, when we are working about when later sessions when we are discussing about deep neural networks, we can see that deep neural networks can easily handle images with labels, right? For example, this is what we see in the right hand diagram. I can just give images of dogs with the labels. I can give lots of images of cats with the cat with the label as cat to the deep neural network. So basically here what we are discussing here is, this is a labeled data set where I am giving labels to the class. Now there's also something called as unlabeled data set, as we have here, right? Our data set, I'm giving just images of dog, I'm just giving images of cat, but I'm not saying to the algorithm that this is a dog and this is a cat. So in unlabeled data set, the algorithm has to actually learn based upon the patterns or sequences of this images. So basically unlabeled data is a label that is not associated with any label. Okay, now coming to the first classification of machine learning algorithm, that is supervised learning. As I told you, supervised learning uses labeled data set. Okay, so that means you have the data with labels. In supervised learning, there is a component called as a supervisor, or you can think that it is like a teacher component, which will provide labeled data so that the model is constructed and it generates test data. In supervised learning, the training data you feed to the algorithm includes desired solutions with the labels. Okay, so in supervised learning, you are giving data, training data to the algorithm, where the training data has labeled data. Okay, now under supervised learning, I have two methods, classification and regression. Now what is classification? See, classification is a supervised learning method. In classification, basically we are going to classify the data, right? You're going to basically give classes, right? Whether it's the initially, like for example here I have a labeled data here consisting of dogs and cats, right? I'm giving a set of training data with a number of dog images and a number of cat images along with their labels. So it's a labeled data I'm giving to the classification algorithm, and a model is generated by our machine learning, right? And it is going to classify. Suppose I give a test data, I'm giving a, let's say the test data which I'm giving is a cat image. It's going to say that the label is a cat. So basically this is a classification problem, because our model is going to say, give an output either as a cat or as a dog. Okay, so in classification the model is either going to classify, in this case either as a cat or as a dog. Suppose you are writing a machine learning algorithm to find out whether the medical image is a cancer or non-cancerous. Then the class in this case would be cancerous, and the other class would be non-cancerous. So classification is basically we are going to give outputs in the form of a class. And what are the inputs that we give to a classification algorithms? In this case I'm showing you some images, right? So we call them as independent variables. Okay, input attributes of classification algorithms, we call them as independent variables. And what is our output? And the target attribute here is called as a label. Okay, so label, or it is a label, is a dependent variable. Okay, so for example, as I discussed in the earlier label data, so these are all independent variables. Okay, the length, width, but class is actually a dependent variable. So you can also give this data set to your classification algorithm. This is a 3-class problem. Okay, because output either is going to say that the image which I've given as in my test data, either is it may say that it's a setosa or a virginica or a versicolor. So this is a 3-class problem. So classification can be any, it need not be just 2 class, it can be 3 class, it can be 4 class or multi classes. Okay, so basically classification problem, in that input attributes will consist of independent variables, which are some of the attributes. It will have dependent variables, which are nothing but the label. And the classification is going to give you an output. Either if it is a 2-class problem, it will have two types of classes in its output, 3-class problem, or it can also be multi-class, more than 3. So there's a relationship now between the input and the target variable, that is a label. So that is represented in the form of a structure that we call it as a classification model. So classification model basically establishes relationship between the input and the target variable. Target variable is the label or the dependent the label or the dependent variable. So basically what is a goal of a classification problem is to predict the label in the discrete form. Why do I say discrete? Because either it can be 0 or 1, either it can be cat or a dog, either it can be a setosa, virginica or setosa or an versicolors. Okay, so basically the label or the output, the goal of a classification problem is to predict label which is in the discrete form. Now coming to the learning. Now the learning will take place in 2 stages. Okay, first stage we call it as a training stage. Right, so the machine learning algorithm or the classification algorithm here, in the first stage it is going to learn from the input. So where it's going to learn from the input, and in the input in this case is always, remember, a labeled data set, because classification is a supervised learning method. Okay, classification is a supervised learning method, and hence the input would be a labeled data set. Okay, so in the first stage the algorithm is going to learn, right? After that learning has happened, that means after training has happened, the samples are processed and the model is generated. Now in the stage 2, the model is tested. So this is the stage 2, where the model is tested with a test or a sample image, and after testing has been done, the model will be assigned a label. It will say whether it is a cat or it is a dog. Okay, so learning takes place in 2 stages. First one is the training stage, and the stage would be the testing stage. So in this figure, what you can see is, after the training has been done, after the model has been generated, suppose I give a test data. What I've given the test data? I've given the values as 6.3, 2.9, 5.6, 1.8. So what is that? These values, this is nothing but the length of the petal, width of the petal, okay, length of the sepal and width of the sepal. Now based upon these values, the fifth value, which is nothing but the label, would be generated. So the classification algorithm will generate a label. Either it will say that it belongs to Setosa, Virginica, or the third one, which is versicolor. Okay, so that's the classification algorithm. Now there are different types of classification algorithms. Each one of this we will be seeing in the future next modules. Some of them, just to name them, you have decision tree, random forest, support vector machines, which are very commonly used from many years. It's used and still very good. Naive Bayes, and finally we'll also be discussing in detail about artificial neural network and deep learning methods, networks like convolutional neural networks. We'll be seeing all of this in the future sessions. Now coming to the regression models, as I told you when I started this session, supervised learning is classified into classification and regression. Classification is where the output would be a discrete value, either 0 or 1, or it can be Setosa, Virginica. So basically that's a classification problem. But what is a regression? Regression, the difference is here in the output. Okay, the output here can be a continuous variable. Right? Suppose I want to predict the prices of petrol. Right? I have given some data sets about what was the prices of petrol over the last 5 years, and I give a training testing data set to predict what would be the price of the petrol next, maybe in the next 1 month. Then the value can't be discrete, it will be a continuous value, right? So that's why in such case it is not a classification problem, it's a regression problem. Regression models, unlike the classification, they predict continuous variables like prices. Okay, so a fitted regression model for a data set will predict the weeks as inputs and outputs product sales. So what we are showing here is, suppose I have a inputs, I'm trying to find out the sales of a particular let's say a product. So on the x-axis I am having the week. This is week 1, week 2, week 3, week 4, week 5. On the y-axis I am having the product sales data. So what I am having here, I have plotted, okay, in week 1 this was the sales. In week 2 the sales was around 1.8. In week 3 the sales was around 2.5. So when you plot, you're actually, if you're mathematically, if you observe, this is actually a linear problem, right? The sales is actually increasing linearly. So this is actually, we call it as a fitted regression model. It's actually a linear regression model, very conveniently we can say, because you can see the output is increasing linearly. So for this, if you just want to come up with an equation, then the output y is equal to function of x, f of x, right? For a regression model, let the input be x, the output is y. What is y? Y is equal to f of x. Now linear regression, here in the figure what we are seeing is, it's training set, and we are trying to put it, we are seeing that we are trying to fit it with a line. Right? And if I try to come up with an equation for this, probably I can come up with an equation like this. The output is 0.66 into weeks plus 0.54. So this is our f of x. What I have on the right hand side of the equation is f of x. So for this, after plotting the graph, so I have come up with a mathematical equation something like this. So product sales is equal to 0.66 into the weeks plus 0.54. So here 0.66 and 0.54 are actually the regression coefficients that we have learned from this data. We got these coefficients because of this data. Now what is the advantage of this, right, regression model? I am able to predict, right, because of using this equation. Now I can predict the product sales for any week value that I give, right? For any unknown week I can predict the product sales. right? Suppose I don't know what would be the product sales for week 8. So just replace this weeks with 8. Right, and I will be able to predict this sales value. And as you can see here is the sales value is a continuous value. It is not any class 0 or 1. It's a continuous value, and therefore it is a regression problem. And this case, this regression algorithm is actually a linear regression. So as I've already told you, both regression and classification are supervised algorithms. The main difference between these classification and regression is classification problems will have outputs in a discrete form. Regression problems will have output in a continuous form. That's the difference. Now coming to the next one, unsupervised learning. In unsupervised learning as opposed to supervised learning, here the training data would be having unlabeled values. There will be no labels to the data. So in the sense what, I will give images of dogs, I will give images of cats, but I will not tell that these attributes values are for the dog, these attributes for the cats. I'm not going to say to the algorithm. So algorithm has to learn itself. It will recognize the patterns, and there are various ways, and the most common way is to use the principles of grouping. Just like if suppose I am given some let's say I am given some coins, I am given some 5 rupee coins, I am given 10 rupee coins. What will I do? I will just group, right, based upon the pattern. 5 rupee coin is a little smaller, 10 rupee coins are a little bigger, so I will group them separately. So the same concept is used here. Based upon the patterns, the objects will be grouped into different groups. Okay, so unsupervised algorithms, some of the examples are, which we will be doing in the next few sessions, is cluster analysis and dimensionality reduction. So these two are examples of unsupervised algorithms. So just to revise, quickly say, unsupervised algorithms will be fed with training data which is unlabeled. So algorithm has to learn itself by recognizing the patterns, and basically they're using the principles of grouping. Two main algorithms, cluster analysis and dimensionality reduction. Now coming to cluster analysis, see this example here. I am having unlabeled data as my training data. I have some dogs images, cats images, but I did not tell which is dog, which is cat. So clustering algorithm is trying to learn by itself, looking at the patterns of these, and it is only going to say, so all these dogs it's putting into cluster 1, cats it's putting into cluster 1, all these images of dogs which looks similar it's putting into cluster 2. So the algorithm is making these clusters based upon the patterns it is seeing in this algorithm, similarities, right? There's a similarity between this cat and this cat, so it's putting into one group. There's a similarity between this dog and this dog, and therefore it's putting into one. So the objective here is to group the objects into disjoint clusters or different clusters based upon its attributes. So basically clustering is a grouping process. Okay, so the data objects of the clusters are very similar, right? So the objects here of one cluster are very similar to each other, and they are quite different from another one, right? See, all these 4 cats are similar to each other, but they are very different from the images which are there in cluster 2. So key clustering algorithms which we will be discussing further is k-means clustering and hierarchical clustering. So some of the examples of clustering processes are segmentation of region of interest. We will see all this. These are some of the examples. Detection of abnormal growth in a medical image. If you want to detect abnormal growth in a medical image, you can go for a clustering process. If you want to determine clusters of signatures in a gene database, you can go for a clustering process, unsupervised algorithms. Now coming to the next one, dimensionality reduction. I've already told you that dimensionality reduction is also plays a very important role in unsupervised algorithms. Now, what is dimensionality reduction? See, first thing is, remember, dimensionality reduction is an unsupervised algorithm. So that means, remember, I'll be giving labels which are unlabeled. Now, it's a very important technique. Whenever when you are doing your projects in machine learning, the first thing you will try to think of is so much huge amount of data, which are very difficult to process, right? You have huge, and you need a lot of data. And in that, there will be a lot of reasons that you don't need to give all that data, right? There will be a lot of redundancies in your data. So, the first thing you try to do is dimensionality reduction, where it's a very important pre-processing step as well. We try to reduce the number of input variables in the data set. So what is dimensionality reduction? It's a technique used very commonly in machine learning and data science to reduce the number of input variables in a data set. But very important is when you are doing dimensionality reduction, you should not lose the integrity and essential structure of your data set. You should not lose important information about your structure. Therefore, you have to be very careful about that. And the advantage of dimensionality reduction is it helps to simplify our data set. It also makes it easier to understand, visualize, and process our data. Now, as I told you, dimensionality reduction involves reducing the data set to few features and without losing the generality. So basically what you observe here is you might have a high dimensional input data as an input, and after dimensionality reduction we are trying to reduce the dimension of your problem, right, thereby reducing the goal, keeping the goal as to reduce the redundant features and yet maintaining the integrity of the data. So dimensionality reduction, primarily it will have two categories: feature selection and feature extraction. Okay, now these two, feature selection and feature extraction, also are part of dimensionality reduction method. What is feature selection? Where we pick a subset of original features, right? How do you want? So basically, if you ask me how you want to do dimensionality reduction, there are various ways. One is feature selection, where I try to pick only subset of original features. I'll try to pick only important features. That also becomes dimensionality reduction. Feature extraction, where we try to create new composite features from the original set. That is feature extraction, where we are trying to create new features, new composite features, taking an original set. So basically these two are examples of dimensionality reduction. Right. Now, what is the advantage of dimensionality reduction? Why do you want to do it? It has a lot of advantages. First of all, it helps to remove the redundant features. Thereby, it will decrease the computation time. Thereby, we also reduce the noise. There will be a lot of randomness in your data. Try to not take that for training. Therefore, it reduces the noise. It also helps in interpretability, improving the interpretability of a data set. There can be a lot of meaning, a lot of data which is having no meaning, right? So if you try to remove that meaningless data, it will improve the interpretability or understanding of your data set, and thereby enhancing the model's performance. So dimensionality reduction definitely will improve your model's performance, right? And also very important thing is, whenever you have high dimensionality data, right, lot of unnecessary information is there in your data, then it can also lead to overfitting problems. When you finally have your output, it can lead to overfitting problems. What is overfitting, underfitting, we'll see later. So therefore, dimensionality reduction will also reduce the overfitting issue. Okay, so these are the advantages of dimensionality reduction. Now the next question is, what methods can I use? Of course, feature selection, feature extraction is there, and some of the most commonly used techniques are also, which we will be discussing further, is PCA, very important, principal component analysis, also plays a very important role in dimensionality reduction. LDA, linear discriminant analysis, GDA, generalized discriminant analysis, and we also have various forms of non-linear non-linear dimensionality reduction methods like TSNE, that is T distributed stochastic neighbor embedding, and autoencoders. Some of this we will be discussing in the next few sessions. So basically, let's try to summarize the differences between supervised and unsupervised. As I told you, in supervised all the data should be labeled. Okay, in unsupervised all the data is unlabeled. In semi-supervised, we will see that later, where a portion of the, some portion we are giving, it's a mix of both, right? Some portion of the data is labeled and lots of data is unlabeled. We'll see that later. So basically the difference is, in supervised learning there is a supervisor component, in unsupervised there is no supervisor component. That means there is no teacher component which is telling us, okay, this is a cat, this is a dog. You don't have that. So supervised will have labeled data, this will have unlabeled data. In supervised learning, it assigns categories or labels. So basically you will be having categories or labels to your data. Here we are doing grouping, right, based upon the similarity between the objects. So that's the difference. Now coming next to semi-supervised. Now there's a lot of times when we are actually working in real time, collection of data is the biggest problem. Okay, and in that you can see that there will be a lot of situations, a lot of times we come across that most of the data would be unlabeled, right, and only some of them will be labeled. So in such cases you can go for semi-supervised learning. right? And if you want to sit and label them also, it can become very difficult, right? Because it's a very costly process. Doing them manually can be very difficult because the data is actually very huge. In such cases, you can go for semi-supervised learning. So in semi-supervised learning, as you can see in this diagram, this is our input data where I have huge data which is unlabeled, and I have only few data which is labeled. So in such cases, go for semi-supervised learning, where you are using unlabeled data by assigning a pseudo label. So what they do is you assign a pseudo label or a false label to the unlabeled data. So labeled data and pseudo labeled data combined would become our training data set. So some algorithms can, there are quite a few algorithms which can deal with such partially labeled training data, where you have some unlabeled data and you have a little bit of labeled data. So that's called as semi-supervised learning. So coming to the next one, when I started with the classification of algorithms, I said there are supervised learning, semi-supervised learning, and unsupervised. And there's one more which I said, reinforcement learning, which is very, very important. Now, what is reinforcement learning? It's very, very similar to what we humans do. Right, we do. Well, when you are trying to teach a child, right, we normally use reinforcement learning. We teach a child, suppose a child is not learning properly, right, we give penalties, right? And suppose a child is doing well, we give some kind of a reward, right, to motivate to learn better. So basically the same concept is used here. Here in reinforcement learning, it mimics the human behavior, just like how our senses are there, right? We perceive the world through our sense organs, and we allow the agents to interact with the environment to get the rewards. Now you have to note down these four important terms which I'm going to say: agents, environment, rewards, actions. So what is an agent? So agent can be a human, or it can be a program which you are developing, right? So agent is basically a program which you are developing. And reward, so basically depends upon what the agent does, how the computer program is functioning and giving output, you give a reward. So suppose a program is doing well, you give positive rewards. Suppose the program is not giving out correct output, you give a negative reward. So basically rewards will help the agent or the program to gain experience, okay, and thereby based upon this experience it will improvise its learning. Okay, so agent is your program. Reward is basically what you get after the program has executed. The rewards can be positive or negative, right? So basically the rewards will help the agent or your program to gain experience. So based upon the experience, again it will learn, right? Suppose it's got a negative reward, it will learn again. So basically the goal is the agent has to maximize the positive rewards. Okay, as I told you, positive or negative punishment. So based upon the rewards, you get experience, the program will get the experience, the behavior gets reinforced and learning becomes possible. Okay, so when you give rewards, the behavior gets reinforced and learning becomes possible. So that is what we are using in reinforcement learning. And very important, or very some very good case studies of reinforcement learning is the way robots are learning to work, right? They use reinforcement learning. Chess, a game of chess, a game of grid, they're all examples of reinforcement learning. When you are designing a robot to work, right, whenever the robot comes across an obstacle, it falls, then that robot learns, it gets a negative reward, and therefore that it takes as an experience and it learns again. So the next time it will try not to sense the obstacle, right? So these are all some examples of reinforcement learning. Let's take this case. Okay, so suppose I am writing a program, right, that the program should be able to play this game of grid. So in this grid game, I have so many grids here. Whenever it comes across this gray box, it means it's a danger. Whenever it comes across this dash lines, so this is basically our goal, right? So the program has to reach the goal. The goal is it has to reach the goal. It can go through these white blocks. Okay, so basically I can say this is like a maze, right? Suppose this is a starting point. It should not it should only it should be suppose this is a starting point. The goal is to reach here, that is the diagonal lines. While going, it cannot go to this gray tile because it indicates danger. It cannot go through the black tile because it's a block. So I'm training my program to reach the goal, right? And I'm also training it saying that black means block, gray means danger, right? So I'm going to write a computer program here with reinforcement learning. So whenever the program is coming across a danger, it will get a negative reward. So whenever it sees another white block, so it gets a positive reward, and it keeps going further. So basically it learns because based upon the learning is reinforced based upon these rewards. So let's say this is the game. So what we are learning here is there is no data here in reinforcement learning. Okay, that should be very clear. In supervised learning, semi-supervised, unsupervised, I am giving training data, but there is no training data here to solve the problem. There's no data here. You have an environment, you have an agent, you have experience and action. So these are the 4 key terms. Okay, environment is basically the grid game. So the grid game is the environment. What are agents? Agents is basically our, let's say, our program, right, which is going to be which will learn through this reinforcement method. The agent will interact with this environment, right, and when it is interacting, it will get some rewards, positive or negative rewards, and therefore gets experience. Okay, so the agent will create a model by simulating many parts. So there I have written my agent, my program, right, where I am simulating many parts. Okay, and it is finding this, and the goal of this program is to find rewarding parts or positive rewarding parts. So experience, as it goes on going through this grid, and based upon these rewards, right, it goes on building its experience. So the experience will help in constructing a model. And I've told you repeatedly again, there is no supervised or labeled data set in reinforcement learning. And the 4th term is action. So the agent will take some action based upon these rewards. Okay, so reinforcement learning is actually reward based, goal oriented algorithm, and it's an area of machine learning which is concerned with how intelligent agents will take actions in an environment to maximize its rewards. And the best example for this, how the robots today, robots are actually learning, right, to walk, to play game, to drive a car. So they are all examples of reinforcement learning. So that was it today. In today's session, we have discussed about different types of machine learning algorithms: supervised, unsupervised, semi-supervised, and reinforcement learning. In the next session, we will discuss about the challenges in machine learning. So I once again request you all to please subscribe to the channel, so you can see various other playlists as well for Python programming and for Python programming for data science. And stay in touch for more videos and more problems with respect to machine learning would be solved in the future sessions. Thank you so much.